Hi Year 6 and welcome back. Hope you had a great half term and welcome to your first maths lesson of the summer 2 term now. So we are going to get started with what is known as, can be very tricky, but I don't think it's that tricky at all if we know some of the basics. And it is of course algebra, okay? We could ask our friend Will about this. What do you think about algebra, Will? Thanks, Will. So now what we're going to do is we are going to get started with the lesson. So what we're going to be looking at today, what we're learning, solving one-step and two-step missing number equations using inverse operations. Okay, a few important words in there, particularly the first one, the equations, which I'll talk about first thing, but we're going to write multiplication correctly in algebraic expressions, and again I'll talk a bit about that. Use concrete and pictorial methods to solve one-step and two-step equations. We're going to look at a bit of how bar models might be able to help us actually a little bit as well. And can solve equations by using inverse operations on each side, particularly the inverse there, very important to this lesson. So, solving one-step equations. An equation is a number statement that uses the equal sign, showing that one side of the equation equals to the other side, okay? So the simple example we've got up here is 5 plus 3. Okay, so I've got 5 plus 3 this side, that is going to be in balance. It's not correct, is it? Okay, we need to have an equal amount on this side, okay? So, if I know that 5 plus 3 is 8, and I put it on the other side, we're okay, it's balanced, okay? So an example here, 4 times 5 is 20, okay? This side equals this side, okay? It's a balanced equation, okay? Let's just have a look at another couple of examples and see how differently we could represent them. If I've got 9 this side, okay, it's no longer balanced, is it? I've got 8 and 9, and I've got 8 on that side. But if I added 15 take away 6 on this side, which is equal to 9, then now I'm balanced again now, okay? Now, let's add another one, 6, we're not balanced anymore. Let's add another one, 24 divided by 4, yes, good, that's equal to 6, now we're balanced, we're okay. And lastly, it's the one I had up here, 4 times 5 on that side, oh no, we're not balanced anymore, but add it on the other side, and now we're okay. Okay, so one side is equal to the other side, okay? Now, as I mentioned a second ago, we can use bar models to help us represent some of these problems. So here's one for you. I think of a number and I triple it. The answer is 18. Okay, so if you think about even the language within there, I triple it. Okay, tripling it in essence is timesing by 3, multiplying by 3. Okay, so if I look here, which one of those could it be? Well done. You've probably spotted it. Okay, when we're talking about the tripling and multiplying, the parts need to be equal, don't they? Okay, so looking down here, which one at the top here has the equal parts? Okay, well, let's have a look. It can't be the second one here. Okay, this one might be, for example, I think of a number, add 3, the answer is 18. Okay, I've got something here, I add 3 equals 18, which would be 15, of course. Okay, this one, I'm thinking of a number and add 9. Okay, I've got 3, 3, 3 here, okay, which is equal to 9. So something plus 9 equals 18. Okay, in this case it would be 9. Now, at the top though, is where we see it, isn't it? Okay, we've got 18, and then I'm going to have to, as I mentioned at the start, inverse operation. Okay, so we're going to have to do 18, not times by 3, but divided by 3, okay, to get myself the answer. Okay, so 18 divided by 3, which is of course 6, okay. Let's have a look at then some other equations and talk a little bit more about algebra then. And in particular, in algebra, missing numbers in equations are represented by letters, okay? Any letter can be used, but often the letter X is chosen, okay? An algebraic X is written to look different to a normal X to avoid confusion with multiplication, okay? It would start getting very confusing, wouldn't it, if we had X's all over the place, okay? So, often we wouldn't see it written like this, okay? 3x times x, it would just get confusing, wouldn't it? Okay, so in fact what we do, and I'll talk a bit more about this, but we put the number next to one of these x's, and that means multiply. Again, this is all revision, you should know this already, but just a refresher here, when you see the number next to the letter, that means multiply by the number. Okay, right, let's have a quick look at one here. X plus 5, again we've got that imbalance there, and 9. Okay, we're balanced now, but I don't know what that x is. Okay, so what I'm going to need to do is I'm going to need to do the inverse, okay? Because I know that something, again we can think about it as our bar model, I've got 9 and x plus 5, so 5 plus something equals 9. Okay, so what I'm going to do is simply do the inverse. If I take away 5 from 9, leaves me with 4. Okay, so nice and easy. It's a one-step equation. I've got 9 and I've got x plus 5. So all I do is simply take away the 5 from the 9 to give me an answer of 4, because 4 plus 5 equals 9. Okay, easy. Okay, let's have a look at another one. Now, as I mentioned a second ago, we're going to look at now one that's got a number with the x next to it, which means multiply. Okay, so the expression is multiply by 3. The inverse operation is divided by 3. We must do this inverse operation to both sides of the equation. So if I've got 15 this side, okay, and I've got 3 here, x. Okay, that means, again, thinking about multiplication, we're talking about equal groups, aren't we? Okay, so that means this number is going to be the same as this number and this number. Okay, they're all equal. Okay, as we did with the last one, okay, we're not going to do addition and subtraction here because we've got multiplication, so we're going to do division. Okay, so I've got a 3x here, so what I'm going to do is divide 15 by 3, and that should give me my x. Okay, divided by 3, and it is equal to 5. Okay, so 3 times 5 is equal to 15. Okay, we've got 3 equal groups of 5. Easy. There we go. Okay, now on to the slightly trickier bits with the two-step equations, okay, where you might need to do some inverse of addition, subtraction, and multiplication and division, okay? So in this expression, 2x plus 4, there are two operations, multiply by 2 and add 4. We look at operations separate to the letter first, which is add 4. The inverse operation is subtract 4. We do this first to both sides of the equation, okay? So if I do this then, plus 4 here, okay, I've got a plus, so simply to the other side, I'm going to take away a 4, okay? So 10 take away 4 is 6, okay, and then look, I've got 2x again here, so that means this here, the two bars here need to represent 6, okay? So because I've got multiplication, I'm going to do the inverse again, I'm going to divide 6 by 2 to give me 3, okay? So we do our subtraction first, and then 2x is equal to 6, so therefore x is equal to 3. Nice and easy. Now, what I'd like you to do now is have a go for yourselves, okay? See if you can crack some of these codes, okay? They're very similar to the examples I've just shown you here, okay? You may need to do some working out from larger numbers with some multiplication and some long multiplication and division, but should be easy enough to do in your head a lot of this, okay? So give it a go, see how you get on. When you find your answer here, whatever the number represents, just find the number up here and put your letter here, and it should spell out a joke. So hopefully it'll make you laugh, just like algebra in general. It's fun. Okay, so I'll see you again soon, Year 6.